Hey there, everybody. Welcome back. Let's do some more examples, or let's do an example of line integrals. This is Calculus 3. We're in 15.2. Let's jump right into it. We're going to evaluate the function 1 plus xy squared along a curve. The curve is parameterized by r equals t for x and 2t for y. And we're going to go from 0 to 1. This is the line y equals 2x. And then we'll do the same thing going in the opposite direction. So we'll go from 1 to 0. And these are how r will be used when we start with y equals 2x. I'll remind you in a later video how we get these. I'd rather get into the line integral now, though. But you have done these r's before. So first off, we need the magnitude of the derivative. So if we take the we're going to start with a. Let's just do a first. We take the derivative and we got 1 and 2. So the norm is going to be square root of 1 squared plus 2 squared is 5. So our ds is going to translate into a root 5 times dt. And now we're free to parameterize it from 0 to 1. So doing the curve or the function 1 plus xy squared over the curve in ds, we're going to change it to everything to t's now. So 0 to 1 is our new integral. Or limits of integration. We got to make sure we plug in t and 2t for x and y respectively. And we turn our ds into the square root of 5 times dt. So when we integrate that, you're going to end up getting 2 root 5. That was us starting at the origin and going to, after t equals 1, going up to 1, 2. Let's do b now, where we go the other direction. So if we integrate backwards, we're using this function, or this vector right here for r. So our derivatives are going to be -1 and -2. And conveniently, we still have the same norm. So square root of 5. Replacing x and y with 1 minus 2t and or 1 minus t and 2 minus 2t. And if you go through the integral, I'll let you work it out. It'll take some time. But when you get through the integral, you're going to get 2 root 5 at the bottom as well. So it doesn't matter which way we integrate along the curve if we're doing the entire ds. Most of the stuff we're going to do in chapter 15 is not the entire ds, but this is the idea of doing a line integral and just finding the area underneath the line, or the function for a two-dimensional thing, or finding something like the mass when the function is linear density, or total heat if it's a temperature gradient, something like that. So the curve didn't matter which way we went, orientation didn't matter. So going whichever way we want that makes it easiest to do this thing works. I think the top way was a lot easier. So when we're free to integrate however we wish, pick the easiest path. Peace.